So for the last part of this unit, we're going to take a look at connecting variation, our direct and partial, rate of change, and the concept of first differences. So first differences, and we're just kind of formalizing something we've already been working with. We've been working with these before. The first differences are a change in consecutive y values given a constant change in x values. It's the rise in the linear relationship. So as an example, we have this table here. Our x's are going up by 1, and then we want to know what our y's are going up by. When you write out your first differences table, what you do is you just kind of put a line through that first value, and then to find it, again, we've been kind of doing this already, but formally we take the 7 and subtract the previous value. 7 minus 4 equals 3. The next one would be 10 minus 7, which equals 3. 13 minus 7 equals 3. And then 16 minus 13, which equals 3. So there's our first differences. They're all 3. It's constant. It would be, the rate of change is 3. That's our linear relationship. And in this case, this would be a partial variation because the initial value is 4. Using the table here, we want to answer some questions. So we want to complete the table and then complete the graph. So let's find the first differences. Same idea as before. Scratch off that one. 5 minus 0 equals 5. 10 minus 5 equals 5. 15 minus 10 equals 5. 20 minus 15 equals 5. So constant first differences here of 5. Linear relationship is what this is going to represent. Now notice here we're working with negative x's, so we're going to have some points on the negative side of the graph. We got negative 4 and 0 as our y value. So a point here. Negative 2 and 5. We're going up by 2, so halfway in between here. So we are going up 2, 4, 6, 8. So do be careful counting on your graph there. 0 and 10. 2 and 15. And 4 and 20. So there's my graph. Now, I make my graphs nice and perfect to fit what we're doing. When you're graphing on your own, you might find that you won't get it all nice and like filling the whole graph. You might just get something up in the top corner, just depending on the grid that you're given. So here's our graph anyways. Is this direct or partial variation? Well, it's not crossing at 0. It's crossing up at 10. This is partial variation. The next question asks us to calculate the rate of change in that graph. Well, we did that. The first differences are the rate of change, and we can check that by making ourselves a little rate triangle. So we draw ourselves a rate triangle here. I'm going to pick 2 points. This one I'm not going to pick because it's not quite on the grid line, even though I know where it is. But I'm going to pick, say, these 2 right here. So these are going to be my rate triangle points. So my rise is going from 10 to 15. And then my run is going over 2. So, or sorry, my run is, what do we got here? My rise is not 15. My rise is up to 15. It's going from 10 to 15. That should be a 5. And that's over 2. So my first differences say it's going up 5 for every 2. Going up 2 here, going up 5 here. My rate of change is 5 over 2, which simplifies down to 2.5. So there's my rate of change. My equation, well, my initial value was 10. And my rate of change is 2.5, so y equals 2.5x plus 10. my rate of change, my initial value, my M, my B. Now we want to look at how the rate of change, first differences, and equation are related. Well, the equation, the rate of change, and the M value here, K value, depending on which version you're looking at, is the same. Here, technically it's the same. It's twice as much. 5 is twice as much, but what's happening here is we're going up by 2. How did we get that value? Well, 5 divided by 2. So the first differences double the other numbers, but going up by 2's all show the same rate. So even though it's twice as big, because we're going up by 2's here, this is a unit rate, this is a unit rate, they are related in that it's essentially the same rate. The table is just doubling it. If we were to go up, if we go to 3, negative 3, it would be 2.5. And then the last bit here, create a table in steps of 2 from 0 to 10 for the equation 15y equals, 15y equals 15 plus 20. And then we want to compare the first differences to the equation. So from 2 to 10, going up in steps of 2, 0, 2, 4, 6, 8, 10. To get the y value, we're just going to sub these numbers in for x. So 15 times 0 plus 20 equals 20. 15 times 2 plus 20 equals 30 plus 20 equals 50. 15 times 4 plus 20. 15 times 4 is going to be 60 plus 20 is going to be 80. 15 times 6 plus 20. 15 times 6 is going to be 90 plus 20 is going to be 110. 15 times 8 plus 20 is going to be 120 plus 20 is going to be 140. And then 15 times 10 plus 20 is going to be 150 plus 20, or 170. Now to calculate our first differences, scratch off the first one. 50 minus 20 equals 30. 80 minus 50 equals 30. 110 minus 80 equals 30. 140 minus 110 equals 30. And 170 minus 140 equals 30. So there's all our first differences. So there's our 30 there. And again, comparing that to that, because we're going up by 2 in the x column, our first differences is double the rate of change in the equation. If we were to go up by 3's in the x column, it would be triple. If we went up by 1's, they would be the same. If we went up by 10's in the x column, this number here would be 10 times the rate of change. So that's some concepts with rate of change and its relationship to the first differences in the table, and just a little more formalizing something we've already been doing and calculating before. Rate of change, first differences, and the rate of change and first differences are different representations of the same thing.